Welcome to Algebra 1. The learning goal for this episode is to learn how to solve and graph absolute value inequalities. Let's look at some examples. We want to solve and graph the absolute value of x is less than 3. First, we need to think about what this is really asking us. What this is actually asking for is all values of x that are less than 3 units away from 0. Therefore, x has to be between -3 and +3. We could write that as a compound inequality like this. -3 is less than x is less than 3. On a number line, the graph would look like this. Notice the open circles on -3 and +3 as there was not an equal sign in our inequality. Then the shading is between those two numbers since x has to be within 3 units of 0. Let's try another example. This time the absolute value of x is greater than or equal to 3. So it's really asking for all values of x that are at least 3 units away from 0. So that's x is greater than or equal to 3, or x is less than or equal to -3, since anything that's less than or equal to -3 will still be at least 3 units away from 0 as well. The graph looks like this. Notice the closed circles on -3 and +3, indicating that those points are solutions. Then notice that our graph splits, with one shading going to the right of 3 and the other shading going to the left of -3. Any point in either shading is a solution of our inequality. Those examples suggest that we have two scenarios to consider. If an absolute value expression is less than some number, as long as that number is positive, then we'll have a solution that is between two numbers on the number line, an AND. For example, the absolute value of x is less than 2 will be between -2 and +2. If an absolute value expression is greater than some positive number, then we'll have a solution that is greater than one number or less than another number, and OR. For example, absolute value of x greater than 2 will be greater than 2 or less than -2. We'll look at what happens when the absolute value expression is greater or less than a negative number in a little bit. Here's another example. This one is a little more complicated. I need to isolate the absolute value expression, so first I add 2 to both sides, and then I divide by -2. Recall that when we worked with inequalities previously, if you multiply or divide by a negative number, you have to flip the inequality symbol. So notice how this now changes to greater than. So now that's asking for all values of x such that the absolute value of the quantity 2x plus 1 is more than 2 units away from 0. So this is an OR scenario. Either 2x plus 1 is greater than 2 or 2x plus 1 is less than -2. Now we solve each of those inequalities, giving us x is greater than 1/2 or x is less than -3/2. The graph then looks like this. Open circles on -3/2 and +1/2, then shading greater than 1/2 and less than -3/2. Just like before, it's always good to spot check a few solutions in the original inequality just to make sure. So you might choose 1 and see if it works. Then choose -2 and see if it works. They both do, so we're reasonably confident our answer is correct. Now for our guided practice section. We're going to work through some problems together. You do not need to write down these problems, just step through them with me. At each step I'm going to prompt you with the question you should be asking yourself, then I'll pause for about 5 seconds for you to think about it and answer it for yourself, then I'll show you. So our first question is, what are we trying to do here? What we're trying to do is solve and graph this absolute value inequality. How do we do that? First, we figure out what this really means. This means that the quantity x plus 2 has to be less than or equal to 8 units away from 0. Now what? Now we set up our two inequalities. X plus 2 is less than or equal to 8, and x plus 2 is greater than or equal to -8. What's next? Now we solve those two inequalities and get our two solutions. Anything else? Yes, we need to graph it. Notice the closed circles on -10 and +6, and then we shade in between. Can we check this? Yes, pick any number in the shaded region and try it in the original inequality. In this case, 0 would be a great choice to check. It works, so that gives me some confidence that my answer is correct. Let's try another one. Again, we're solving an absolute value inequality. What should we do first? We isolate our absolute value expression by adding 2 and then dividing by 3. What's next? Next, we think about what this means. This means our quantity, y minus 4, is more than 4 units away from 0. That allows us to set up our two inequalities. Y minus 4 is greater than 4, or y minus 4 is less than negative 4. What's the next step? Solve those inequalities. Now what? Now we graph it. Open circles on 0 and 8, then shade appropriately. Again, a good idea to check a couple of solutions, one from each shaded area, just to make sure they work. Let's try one more. What do we do first? We isolate the absolute value expression by dividing by negative 2. Note that we have to flip the inequality sign to greater than because we divided by a negative. Now what? Now, this is where it's even more important to really think about what this is asking. It's asking for all values of x such that the absolute value of the quantity x plus 4 is greater than negative 4. But we know absolute value is always positive, so no matter what we fill in for x, it's going to be a solution because it's going to be greater than negative 4. Therefore, our solution is all real numbers. We're done. Note that this had been less than negative 4, we would have had no solution because there's no way an absolute value expression could be anything less than 0. Now for the self-check section. In this section, you're going to physically pause the video as you work out the problem on paper in your notebook. Then you'll press play to check to see how you did. You'll have 5 seconds to pause the video after I stop speaking before I show you the solution. Please pause the video now and work out the problem, then press play to check. Here is the solution. Please compare this to your work. Pause the video here if you need more time to compare, then press play again to move to the next problem. Same thing on this problem. Pause the video, write down this problem and work it out in your notebook, then press play to check. Please pause the video now. Here's the solution. Again, pause the video if you need more time to compare this to your work. In closing, let's review our learning goal. We wanted to learn how to solve and graph an absolute value inequality. We did that by isolating the absolute value expression and then considering two main scenarios. Either it was less than some number, in which case our solution would be between those two numbers, or it was greater than some number, in which case our solution was greater than one number or less than the other number. We know an absolute value expression can never be negative, so there are some scenarios that have no solution or all real numbers solution.